Good evening, dear viewers. Today we have taken a problem from definite integral. Here, for each positive integer n, define a function fn in the closed interval 0, 1 as follows. Fnx is equal to this, that is fnx is defined in several sub-interval of 0, 1. 0, 1 is divided into n sub-interval and function is defined in each sub-interval as equal to 0 when x equal to 0. In the semi-closed interval 0, 1 over n, function is sin pi over 2n. In the semi-closed sub-interval 1 over n, 2n as sin 2 pi by 2n, and sin fnx is equal to sin 3 pi over 2n in the semi-closed interval 2 over n, 3 over n, and so on. And in the final interval, that is final semi-closed sub-interval of 0, 1, 0, 1 closed interval, function is defined as sin n pi over 2n. In the finally we have taken the semi-closed interval sub-interval of 0, 1, which is n minus 1 over n, n by n, that is 1. Function is defined in each sub-intervals of the intervals closed interval 0, 1. This is split function. This is called split function. This is piecewise defined. This is sub-interval wise defined function, and also function is constant in each sub-interval and different constant value. It has different constant values, that is function is constant in each sub-interval, but the constant values are different. We have to determine the value of limit n tends to infinity 0 to 1 fnx dx, that is we have to find out the limit of definite integral 0 to 1 fnx dx. Now let us begin. Here function, at first we find out the value of definite integral 0 to 1 fnx dx. Our first step is to evaluate the definite integral 0 to 1 fnx dx, and then we shall find out the limit of the definite integral, that is limit n tends to infinity of the definite integral. We have to determine this value. Now we can also write 0 to 1 fnx dx. From the properties of integral, we can write 0 to 1 over n fnx dx, 1 over n, 2 over n fnx dx, 2 over n, 3 over n fnx dx, and so on. Ultimately n minus 1 over n, n over n, that is 1 fnx dx. This is written from the property of definite integral. This is the properties of definite integral. This is the any definite integral can be written as the sum of the integral in each sub-interval of this entire interval. If the entire interval divided into n sub-interval, in n sub-intervals, the integration of the function is equal to sum of the integral of the function in several sub-intervals is equal to the entire definite integral. It equal to the entire definite integral. It is the property of integral. It is written from the properties of definite integral. Now equal to, and also we are given the function is constant in several sub-interval. Function is constant in several sub-interval of the closed interval 0, 1. So in the interval 0, 1 over n, in the semi-closed interval 0, 1 over n, function is constant, its value is sin pi by 2n. So we can put the value of the function as sin pi 2 over n, sin pi over 2n in the semi-closed interval 0, 1 over n. This is, and also in the semi-closed interval 1 over n, 2 over n, function is defined as constant. This constant is sin 2 pi over 2n. So we can put this constant value in the interval 1 over n, 2 over n, that is sin 2 pi dx. And also in the semi-closed interval 2 over n and 3 over n, function is defined as the constant function whose value is sin 3 pi over 2n. This is the constant value of this function. Function is constant in this semi-closed interval, that is 2 over n, 3 over n. So we can put this value dx and so on. Ultimately n minus 1 over n, n over n equal to 1. In the last semi-closed interval, that is n minus 1 over n, 1 and 1, that is n by n. The function is defined as constant function. The value of this constant function is given as sin n pi over 2n. So we can put this value sin this is the integrals. This is written as from the property of definite integral. The property is the any definite integral in a interval, in certain interval, is equal to the sum of the integrals over its sub-intervals. Here n number of sub-intervals is n, that is n sub-intervals of the interval 0, 1 is taken. That is 0, 1 is divided into n sub-interval. These n sub-intervals are 0, 1 over n, semi-closed interval 1 over n, 2 over n, semi-closed interval 2 over n, 3 over n, and so on. And lastly n minus 1 over n, n over n, that is 1. This is also semi-closed interval, semi-closed sub-interval of the entire interval 0, 1. So here we can, this is constant, we can write integration of dx is x, integration of dx is a, this is constant. So we can write this 1 over n, 2 over n, sin 3 pi over 2n, x limit, upper limit is 3 over n, 2 over, lower limit is 2 over n, and so on. Lastly sin n pi over 2n, x n minus 1 over n, 1. These are the integral on its sub intervals. These are the integrals, in value of the integrals over sub intervals of the interval 0, 1, of the closed interval 0, 1. The value of these integrals are this, and we can write this as 1 over x, x upper limit is 1, value of x, upper value of x is 1 over n, and lower value of x is 0. So upper limit minus lower limit, we can get 1 over n minus 0, that is 1 over n. the value of this is 1 over n, that is one over n. Value of this is also one over n. 2 over n minus 1 over n is 1 over n, and also this value is sine 3 pi over 2n. This is also 1 over n. 3 over n minus 2 over n, that is upper limit minus lower limit, is 1 over n. In each value of these functions are 1 over n. Each value of this function is 1 over n, and this is also n pi over 2n. This is also 1 over n. 1 over n. So we can write this as the summation sine r pi over 2n 1 over n. This sum is written as in consolidated form. This form is summation sine r pi over 2n into 1 over n. This is the summation of this sum. That is, this sum is written in the summation sine r pi over 2n into 1 over n, where r equal to 1 to n. R equal to 1 to n. This is the value of this definite integral. That is, this is the value of this definite integral. This is the value of this definite integral 0 to 1 fn x dx. Now we have got zero to 1. We have already got 0 to 1 equal to summation r equal to 1 to n sine r pi over 2n into 1 over n. That is 1 over n summation r equal to 1 to n sine r pi over 2n. This is here we can take 1 over n equal to h, that is, if n tends to infinity, then h tends to 0, then h tends to 0. So we can transform it as limit here transform as h summation r equal to 1 to n sine r pi by 2 h. This is r pi by 2 h, and you can write h summation r equal to 1 to n r equal to 1 to n sine r h pi over 2, r h pi over 2. This is the sum. And if we take fx equal to sine x pi by 2. If we take fx equal to sine x pi by 2, then f of RH equal to sine RH pi over 2. If we take fx equal to sine x pi over 2, we also get f of RH equal to sine RH pi over 2, that is, this is the function sine RH into pi by 2. So we can write h r equal to 1 to n function of RH. This is, if we take limit n tends to infinity on both sides of the equation, the equation is 0 to 1 fnx dx equal to h summation r equal to 1 to n f of RH. If we take limit n tends to infinity on both sides of this equation, we get limit n tends to infinity 0 to 1 fnx dx equal to limit n tends to infinity h summation r equal to 1 to n f of RH. This is also, if limit n tends to infinity, we have got h tends to 0, because 1 by n equal to h is assumed. So if n tends to infinity, then also h tends to 0. So we can write limit n tends to infinity as limit h tends to 0. Limit h tends to 0, h summation r equal to 1 to n f of 0 plus RH. That is, here we can take limit h tends to 0 h into summation f of a plus RH, r equal to 1 to n, here a equal to 0 and nh equal to 1. nh equal to 1, that is 1 minus 0. This is equal to b minus a. From the definite integral, this is the length of the entire interval, that is b minus a. Here interval is 1 0, entire interval is 0 1. So this is the length, this is the length of entire interval ab. So b minus a, here a is 0, so b equal to 1. So b equal to 1, because a equal to 0, so b equal to 1. And also this is the limit of a sum of the function. This is the limit of a sum of the function. This obey the definition of definite integral. This obeys the definition of definite integral. And definition of definite integral is the limit of a sum. Any definite integral can be written as the limit of a sum. This is the limit of a sum, and this limit of a sum is also the definite integral 0 to 1 fnx dx. This is the definite integral 0 to 1 fx dx. Here fx dx, where fx equal to sine x pi by 2, where because f of RH equal to sine r h pi over 2, so here fx equal to sine x pi over 2, here RH is taken as x, here RH equal to x, here RH equal to x. So this is fx dx, this is fx, this is the limit of a sum, and this limit of a sum is equal to the definite integral 0 to 1 fx dx. Here fx is sine x pi over 2, because f of r is equal to sin rh pi over 2, where rh is equal to x. Rh is taken as x. So the value of this limit is limit n tends to infinity 0 to 1 fn x dx equal to 0 to 1 fx dx. Here 0 to 1 fx is equal to sin x pi over 2. Fx is defined as sin x pi over 2. So we can put the value of fx is, which is sin x pi over 2 dx. So if we integrate this function, we get minus cos x pi over 2 over pi over 2, limit 0 to 1, that is 2 over pi, upper limit is minus 1, that is minus 1, upper limit is 1, that is sin cos x pi over 2 is cos pi over 2, because x equal to 1 in for the upper limit 1. So value of this function is at the upper limit is cos pi over 2. Cos pi over 2 is 0, so this is 0, minus plus, and for the lower limit the value of this function is cos 0. Cos 0 is 1, so this is 1, 2 over pi. So this is the value of this limit. This is the value of the limit. We have got the value of this limit, and this is the value of the limit of the definite integral 0 to 1 fn x dx, whose value is got as 2 over pi.